Okay, all right, well, good morning and happy Monday. Today I want to talk about tidy data, as this is how I recommend that you organize your data as you work with it. So let's talk about what this involves. Okay. I'm going to kind of cover several packages from the Tidyverse in this class. So today we're going to take a look at tidyr, but then in future classes or future, sessions, we'll look at ggplot, things of that nature. A lot of this stuff come from this textbook called R for Data Science. You can read it for free in your browser at this address. Highly recommended. All right, so the Tidyverse describes itself as an opinionated collection of R packages designed for data science, and all the packages share an underlying design philosophy, grammar, and data structures. And then these are, a list of packages that get loaded when you call library tidyverse. So if you haven't done so already on your computers, you should probably do install.packages tidyverse, and then it will install a bunch of these packages. And then when you call library tidyverse, it will load a bunch of these things up. And so we'll look at some of these. Okay. All right. So the first thing that we should talk about is tibbles. Tibbles are basically data frames. Okay. Except they have kind of a few nice little features that just make them a little bit nicer to work with. So R, I wrote R is an old language, and some things that were useful 10 or 20 years ago kind of now get in your way. And again, it's difficult to change functionality of base R without breaking a bunch of other stuff that depend on it. So a lot of kind of innovation and stuff occurs in these add-on packages that a bunch of developers work on and stuff like that. And so the Tibble package, along with the rest of the Tidyverse, provides what they call opinionated data frames. And you're like, how can data frames even have an opinion? But it's the idea that your data needs to be structured in a certain way for Tibbles to work. Okay, and so here this is just an example. So basically, instead of data.frame, we have Tibble, and then we can define our different columns, and these are just arbitrary columns. So we've got column A, column B, column C, column D, etc. Okay, and Tibbles, when you work with them, they have their print method only shows the first 10 rows and only the columns that fit on the screen. And that makes it nicer to work with large data. I don't know if you've ever had the experience in R where there's a data frame that's in your thing, and you say print data frame name, and then it just dumps a whole bunch of stuff on your screen, and it's hard to even navigate and stuff like that. And Tibbles basically avoids that from happening. So here we've got a few columns, and it just kind of fits the first 10 rows, and it just kind of fits what fits on your screen as well. So, and then column D, they're just kind of random values here, but they're rounded off to basically 3 significant figures. The entire number is stored, but as far as what shows up in the display, just a handful of significant figures show up. Okay. A couple things as you're working with Tibbles is that when you subset a Tibble using single square brackets, it will always return a Tibble. If you want to reduce it down to a vector, which is kind of the behavior that a data frame does, you have to specify an optional argument called drop equals true. But for example, if this were a data frame, if you just select the first column like this, it will often reduce it down to a vector. Okay, if you want it to remain as a tibble, okay, I mean if you with a tibble, if you do a single square bracket, it will always remain a tibble, even if it's just a single column. Okay, so just in contrast, here's the data frame, the same. So this is basically the same thing. This is a tibble. I use single square bracket and I select the first column. It remains a tibble. Here, with data.frame, if I select that first column, it just automatically reduces to a vector. So that's something to keep in mind, okay? If you do want this, and sometimes you do, you can specify drop equals true, or there's a function you can call called pull, and that will, you call pull, P-U-L-L, on this thing, and it will pull out the values as a vector. Okay. If you do want to extract the column as a vector from tibble, you can use double square brackets. Okay, so with the tibble, double square brackets will reduce down to a vector, and then $sign notation will also reduce down to a vector. And this is the same behavior that data frames have. So the primary difference is this thing: single square brackets always retain the structure of a tibble. Okay. Creating a tibble is basically the same way as you create a data frame, and then also if you have an existing data frame, you could just wrap it in tibble, and that will basically upgrade from a data frame into a tibble. And again, tibbles and data frames are pretty much, the same thing, pretty much. But again, there's a few kind of nice little features of tibbles that make, in my opinion, make it a little bit easier. Okay, and again, this decision, this design choice for single square brackets to always remain as a tibble, that's part of the opinionated forms that the creators felt that the notation should be uniform, so single square brackets should always remain as in the form of a tibble and things like this. Okay. Sometimes if you want to enter the data in yourself, okay, when you fill out data, we generally write them as in row form, right? So this would be like column A and then column B, column A, column B, so on and so forth. But the way R fills it out is it generally fills out column-wise. So if you have a vector, it goes down the column, which makes it kind of annoying to have to like fill things out. So if you want to fill it row-wise, you call tribble, T-R, tibble with an R in the side there, and this will create a row-wise tibble. Okay. As far as significant figures go, tibbles just have a tendency to display only a handful of significant figures. I think the default is like around 3, and so you can see these numbers here I'm creating in column A, 9.87654, and then 1.123456, and then here the default is it just kind of prints out the first 3 significant figures. Again, it retains all of the information. It's not rounding them off. It's just when it comes to display, it only shows the first 3 significant figures, and that's just so it can fit as much kind of information as possible on the screen. If you do want to retain more significant figures, and a lot of times you do, you can specify options, and then you'll say pillar.sigfig, and then say I want 5 significant figures or something like that. Okay, and you can see it does that, and then this 4, as far as displaying goes, gets rounded up to a 5 there. Okay. Let's talk about pivoting data, as this is how we often get data from different sources and try to get it into tidy form. Before I do that, let me go ahead and give you your first view quiz answer. Oh, you know what? I always forget the access time needs to be available from 8 a.m. Okay, so. Sorry, give me a second here. Okay, for today's first view quiz answer is the letter B. B as in bear. B is your first view quiz answer. Okay. All right, so this is the philosophy of the tidyverse, or the opinions, and it is that every column is its own variable, so each column should be one variable, and each variable gets its own column. Every row is an observation, okay? And every cell is a single value. Now, there's a caveat, or a kind of a catch when we say every cell is a single value, because you can actually have kind of like lists or vectors within a single cell, okay? And that is still within the philosophy of obeying the Tibble. But you have to explicitly kind of tell, I guess, R and the Tibbles that this is kind of going to be the form that you want to contain multiple values within a single cell, okay? But here's an example of data that is in tidy form. This is data from some tropical storms, and they have the name of the storm, and then I guess the wind speed and the pressure and the date of the storm. Okay, and so each of these variables get their own columns. Okay, and our variable names are storm name, wind speed, air pressure, and date, and when you have data that's in tidy form, you can do operations that, vectorized operations, okay? Here, so again, you might have data that looks kind of like this, and one could argue that this is already in tidy form, but I guess depending on, what the variables are, you might want to reformat this as well. You might want to pivot this, okay? And so, as it's presented here, each row is a country. And then across the rows, we have, how many cases of, I think this is some fictional disease, how many cases of the disease occurred in 2011, how many cases occurred in 2012, how many cases occurred in 2013. One could argue that the variables that exist in this thing are actually the country and the year, and then the count of the cases. Okay, and the count of the cases are arranged, kind of spread throughout here. And so, what if you wanted to do some kind of operation this way, restructuring your data in this form, could prove to be a little bit tricky. Okay. Here's another data set. And again, this is one form that the data is in, okay? In this row, we have the number of large particles in New York, okay, the number of small particles in New York, the number of large particles in London, and so on and so forth. This is like, I guess, air pollution numbers. Again, there's some fictional numbers made up, okay? Now, one could argue that perhaps the variables here are really just the city, okay? And then we should have a column for the amount of large particles, and we should have a column for the amount of small particles. And if you wanted to kind of do a difference or a ratio between the amount of large particles divided by the amount of small particles or something like that, that would be really difficult to do with the data in this current form. And so this, when you have data in this kind of form where they're not in columns, okay, like this, then we have to do what we call pivot the data, okay? So this is just kind of taking the data and rearranging them, okay? So we're not deleting any data or anything like that, but we're pivoting them. So we're changing how it's arranged in the table. And so we have functions within R that will help us with that, okay? This data is available, these toy data sets, okay, are available as CSV files on GitHub. And here I'm going to just use read_CSV and just put in the URL of those CSV files because they're directly available on the web, so I can just read them in and they get read in, okay? And so this is an example of why we like having our data in tidy form, and that is we can do vectorized operations. So if I wanted to calculate something like the ratio between pressure and wind speed, I don't know if that means anything, okay? But you know, if I wanted to do something like this, if I wanted to do 1007 divided by 110, all I have to do is I just define the new column, $ratio, as storms $pressure divided by storms $wind, and this automatically, R will automatically kind of just do row-wise operations, okay? And it's going to just kind of do the next thing. 1009 divided by 45 gives us this thing, and this is what we have. And this allows us to kind of do certain operations. It's not unusual, right? Like if you can imagine having data where you have someone's height and someone's weight, and then you want to do a calculation to figure out BMI. Okay, you could do that, right? You could do I don't know, whatever. Whatever you want, right? If they're in column forms, you can just kind of do these things. And if it applies to the same observation, you know, you can do that. If you have the housing prices, you can do like, I don't know, the difference between the, you know, if you have like how many, total square footage, but then you also have basement square footage or something, you can add those two together or something. So you'll have like ground square footage, which doesn't include basement. I mean, we're in California, so like basements aren't a thing, but in a lot of the other part of the country, basements are a thing, and like it, you know, I don't know, the way you calculate square footage of a house is, you know, a little bit weird and stuff. Okay, all right, but what if you have data in this form? Okay, and you know, I mean, so this data is reasonable if you wanted to do like, okay, how many cases changed from say like 2011 to 2012. You would want the data in this form because you can do that kind of comparison. How much did it change from 2012 to 2013? Okay, so in sometimes this data form is totally fine. Okay, but what if you have so you know, let's say this is fictional disease A, okay, and then let's say you have another data table that looks just like this, and it's like fictional disease B, okay, and you wanted to kind of do some kind of comparison between disease A and disease B over time for these different countries and stuff like that. Okay, now, you know, if you were to just try to group the two tables together or join them together, it's kind of hard because you have, you know, the number of cases of disease A in 2011 for France, but then you'll also have, you know, so it probably makes sense to pivot this data so that one column will be the country, one column will be the year, and then we'll have a column for the number of cases of disease A. And then if we have another table formatted, we could also just add the column for the number of diseases for case B and things like that, okay? So I don't want to say like this data is good or bad in its form, right? If you have certain operations you want to do, like comparing from 2011 to 2012, this is the correct format. But if you have like another table of different disease and you want to kind of compare them, this format doesn't work well. So it needs to be restructured, okay, or pivoted, okay. So if we want to kind of make this tidy in the form where we're going to have a column for the country, a column for the year, and a column for the count, okay, what would the resulting dimensions be? How many columns, how many rows would we have? We're going to just do this table right here. Okay, well, let's start with the easy one. How many columns? 3, right? And I have them listed right here. Each variable gets its own column. So the columns will be country, year, and count. Okay, how many rows? We will have 9 rows. We've got 9 values here. Each value is going to get its own row. Okay, so we're going to have 9 rows. So if we restructure it, okay, and I think I actually have this wrong. I think it'll be sorted by country first. So it'll be like France, 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 France 2011, France 2012, France 2013. But basically, these 9 values get rearranged into this column for N or count, and they're all here, okay? So all of the data retains, it's just restructured into this form, okay? We call this long form, okay? And this would be wide form. So And it's long because there's more rows. Okay, it's longer. Okay, so the operation, the function we use is called pivot longer. Okay, so the resulting data set is going to be longer than the other. If you look at older versions of tidyr, it's called gather, okay, because I guess they're like gathering multiple columns into one column, but they renamed it to be pivot longer. It seems to be, I guess what we prefer. Okay, so the call, okay, is you say take your current table, so pivot longer. What are you gonna pivot? The cases table, which looks like this, okay? This is the cases table, and we're gonna pivot longer. The columns that are basically going to be pivoted, okay, are the columns 2011 to 2013. We're gonna pivot these three columns into one column is what's gonna happen, okay? And then when you do that, the names of those columns, okay, go into one column, and then the values go into another column. Now we have to provide names for what it's going to go into. So the names go into a column, and we're going to just call that column year, and the values go into a column, and we're going to call that column called cases. Okay, so the calls are the names of the columns that will be pivoted, and so we are pivoting the columns 2011 through 2013. Okay, and here we can use the colon to specify a range of columns, or you can provide a vector of column names. This is going to assume these columns are all adjacent, okay? And then this is just an arbitrary character string for whatever you want to call that new column, and so is this, okay? Years and cases. These are optional arguments, okay? But it'll just be, I think it'll just call name and value if you don't specify anything. Okay, so here I've just provided arbitrary names. This would be a terrible name to use for your columns. Don't put spaces in your column names, okay? Because anytime you want to reference that column, you have to use backticks in order to reference the column, right? You have to do $, and then backtick, and then the thing with the spaces. So, but I mean, technically it's allowed, okay? So, here I created the column called when it happened, and then this column is called how many. And again, these are just arbitrary names. There's no actual meaning for it. Certainly years and cases make sense, but that's fine, okay? And then, your column names, also you want to generally avoid numbers as your column names, because again, it requires backticks, so you can see these things being backticked. Okay, so here's a question. What would happen if I only pivot the columns 2012 and 2013? How many rows will I end up having? I'll end up having 6 rows, okay? Because I have 6 values. They're gonna get pivoted, okay? And then what will the columns be? The resulting columns. So basically anything that doesn't get pivoted gets duplicated. So it's gonna feel a little bit strange, but country will get duplicated, but so will this column 2011. Now that feels strange, but it's just any column that doesn't get pivoted will get duplicated. So the result will have a column country and 2011, because those ones did not get pivoted, and the ones that did get pivoted, is that the right form? The ones that we did pivot, okay, go into the columns that we provided the names for year and cases. So the 2012 and 2013 will have France 2012 6900, France 2013 7000, DE for Germany 2012 6000, DE Germany 2013 6200, and so on. Okay, and then the ones that did not get pivoted, okay, country gets duplicated, and then this column 2011 also, it did not get pivoted, so it just kind of gets duplicated across here. Okay, now we look at this and we go, oh, that was a bit of a mistake, but that's what happens. Okay, tidyr doesn't have any kind of reference of like what the meaning of your data, so it doesn't care. It just it's just going to do what you ask it to do. And here we just asked it to pivot these things, and this is what we want. Okay. All right. What would happen if I try to pivot all 4 columns? If I try, you're like, is that even possible? Kind of. Okay. So if I try to pivot country, so if I say pivot country 2011, 2012, and 2013 all together, what would end up happening? Okay. So we would end up having 12 rows, okay? And we would have a column named, well, okay, actually, so when you first try this, tidyr is going to stop you. It's going to say, you have character values and numeric values, so I don't want to do that, okay? So it's going to say, I can't combine character and double, okay? But, we can kind of twist its arm and force it to do it anyway, okay? And what I can do is I could turn everything into character. I can just convert all of the doubles into characters. Again, this is like going out of your way to hurt yourself. It's like, I don't know, intentionally, disabling your airbag and then trying to crash your car or something. Okay. So, don't do stuff like this, but as a curiosity, what would happen? Okay. So here I converted everything into character. So everything kind of works as a character. And then I say, all right, now pivot everything longer. Okay. And what happens is this, okay? Basically all of the values, okay? So the names go to name and the values go to value. And so, it says you had country and the value was France, and you had 2011 and the value is 7,000. And basically, it's like you have a X and a Y coordinate, kind of. It's just you had a row name and a column name, okay? And you could define every single kind of value this way, right? So row and values, something like that. Okay, so this is what ends up happening if you did that. So again, not recommended, but not impossible. Okay, let me give you your second view quiz answer. And today's second view quiz answer is the letter E. E as in elephant, E. Okay. All right, so here you have the pollution table, okay? And again, this kind of data could be fine in this form, especially if you have these were the pollution numbers in, I don't know, let's say 2010, and then you have another data set that's for 2020, okay? And you want to compare how much did the large particles change from 2010 to 2020 or something like that, right? So again, how your data exists might be perfectly fine in its form, or you might actually need to get your data into it is possible that your data comes in like this, and then you want to convert it into this form, okay? So, and again, everything depends on your use case. So this form might be okay. All right, so this is what we have. But let's say I wanted to pivot this data, okay? And so I want to have the variables, the resulting variables. I want a row for city, a column for city, a column for large particle amount, and a column for small particle amount. So if I do that, what would the dimensions be of the resulting table? So how many columns? We'll start with that. We're gonna have 3, right? And it's just these: city, large particle amount, small particle amount. Okay. How many rows will I have? I'll also have 3. Okay. I will have a row for each city: a row for New York, a row for London, a row for Beijing. Okay. So this is what we're gonna have. Okay. Again, just some made-up numbers here. And so if we pivot this, okay, this is what we would end up having. These 6 values will get pivoted into these 2 columns, the column for large and the column for small. And so again, all of the data is retained. It's just we've pivot the values. So this operation to go from long form over into this form, this is called pivot wide. Okay, and so they're kind of reverse operations. So this one is going to be pivot wider, and what we're going to do is we're going to say, hey, take this table, the pollution table, all right, and then pivot. Basically, the names come from this column size, and the values come from this column amount. Okay, so names from size, values from amount, and there it goes. Okay, and it does it. So that's it. That's it. So the names is the name of the column that has the names that will become column headers. All right, so here our column headers will be large and small, and those names are in the size column, and then the values come from the column of the values. Okay, so I think that's pretty straightforward, and so that's what we have. Now, pivot wider is very sensitive to any kind of spelling differences. You know, it's case sensitive and things like that. So if your data looks like this, okay, so here I just changed the first value from New York into NYC, okay? If I pivot this wider, if I take this thing and I pivot wider, how many rows will I end up having? I'm going to have 4, okay? We're going to have basically a row for each unique city name that I have, okay? And again, R has no idea, you know, it doesn't have any kind of semantic vocabulary. It doesn't know that NYC and New York are referring to the same thing. As far as it's concerned, those are totally different entries, and they are, okay? And so we're going to end up getting 4. So then what happens to like NYC small or New York large? Okay, they get filled in with NAs. Okay, so this is what ends up happening, right? Is that we get 1 row for each unique value in city, okay? And then the large, okay, for NYC is 23. That's what it identifies, but then there's no NYC small, so it gets filled in with NA. Okay, same kind of thing with New York. New York small gets filled in, but large, it gets filled in with an NA. Now, if you want, you can put in a fill value. So instead of NAs, you can put in 0 or something like that. Okay, so you can specify a fill value. You got to be careful though, right? Because let's say if you were dealing with like the average large value or something. Okay, now throwing in extra zeros is going to bring your mean down, right? So maybe that's correct. So maybe if no value is recorded, it means there was 0 observations recorded or something like that. And so maybe 0 is correct. But then in other cases, if nothing was recorded, it just means we didn't, there is a number, but we just don't know what it is, then NA is the proper thing. So, so sometimes, again, you have to be aware of your data to know what the right step should be, okay? And then, other times you're like, oh, I'll just fill in missing values with the mean of the other values. Sometimes that's okay, and other times it's like, no, don't do that, okay? What happened there? Weird. Okay. This slide just doesn't want to appear. Wait, okay, so this goes, and this, all right, okay. All right, whatever. All right, here's another example. Okay, here I have large in all caps here. So so the cities are all spelled correctly: New York, New York, London, London, Beijing, and then I've got size, all caps, large, small, large, small, large, small. Okay, what happens if you pivot this? So I guess our clue is going to be names come from the size column. Okay. So our new columns, we're going to get a column for each unique value in the size column. So we're going to end up getting a column for all caps large, a column for small, lowercase small, and a column for lowercase large. So the unique values that appear in the size column each get their own column in the resulting pivot table. So this is what ends up happening is, you know, a row for New York, London, and Beijing, but then all caps large gets its own column. And again, because it's the only one that's spelled that way for New York, then we get NAs over here, and then the lowercase large gets its own thing. So you know, I guess just be aware of this. So pivoting data is super handy and super useful. You do sometimes run into issues like this, okay? Especially if you're like, if you like highlight a table on the internet and then you copy and paste it. So if you're gonna do something like that, like Arvest does a better job than highlighting and stuff. But if you do highlight, sometimes there's like invisible like space characters after certain things. And then like R is gonna treat those separately. Like if there's large followed by a space and large followed without like no space afterwards, it's gonna see those things as different things. And you'll get stuff like this and you go, I gotta clean all of this up. Okay. All right, so these are reverse pivot longer and pivot wider are inverse operations. So here is pollution, and we saw this pollution table and I pivoted it wider into this, okay? But again, you might have data in this form and you want it back in this form. So this is useful if you wanted to calculate like, oh, what's the ratio between large particles and small particles or something like that, okay? It's useful to have in this here, okay? But if it could be useful to have in this if it's like, this is, you rename this to like amount in 2010, and then you have another data table and it's going to be amount in 2020, and you want to record like how have these numbers changed, and now you want those things in column form. So then so the longer form might be better, okay? So in that you can take the wide table and you would just pivot longer, okay? So how do we do this? We're going to say we're going to pivot the large and small columns, and when we pivot that, that's going to go to the column. We're going to call that column size. We're going to call the values into amount, and so you get the exact same result. Okay. Same thing with the cases table. So you could have this, and this kind of form would be useful if you wanted to do like count of disease A and then another count of disease B or something like that. But if you have, if it's in this form, you could just say, you can do comparisons between 2011 and 2012. How much did it change from year to year or things like that, okay? And so here it is in longer form, and you would pivot into wider form. So here it is pivot wider, and so longer form, and you get it back, okay? So longer and wider, these are inverse operations, and that's that, okay. I guess that's it for the main part of this lecture. I know homework 2, I think is you guys are wrapping that up, and a lot of you guys have submitted that. I've already posted homework 3. I know it's just like, oh gosh, like this, welcome to the quarter system, right? So it's so homework 3, you can start to take a look at that. The first few entries will work. Well, actually, the first problem deals with dplyr, which we'll cover next week, or I mean, in Wednesday's lecture. And then, but you also have some operations where pivoting the data is going to be useful as far as doing the calculations that you need to do. So we'll do that. Okay, let me give you your last view quiz answer. Last view quiz answer today is the letter A as in apple. And we'll wrap it up. Let you guys go a little bit early today, and we'll see you on Wednesday.